moving on, y2 minus 6 equals 10. This entry is equivalent to that entry. So y2 equals 16. And y3 minus 2 equals 10. So y3 equals 12. So we have these points, and remember what this stuff is. This is a translation matrix. This is exemplary of a translation matrix. This is where everything moved. These are my coordinate points right here. I have this x2 and y2. This relates to u prime. Those are the coordinate points for u prime. And I have this x3, y3. These are the coordinate points for g prime. So if we go back to the earliest question, find the coordinates of u prime and g prime under this translation. Well, keep in mind we found they gave us m prime. They gave us its -3 and 6. U prime is this x2 and y2. So what's x2? x2 is 1. And what's y2? That's 16. So this is 1 and 16. Now I'm just putting it back into this matrix. I'm not sure why. I might as well just solve for, or put them in as coordinate points. But g prime is at 2, 12. Let's put them up here. 2, 12. So if you want to write your actual answer, and let's see if I remember those points exactly, we'll have u prime at 1, 16, and g prime is at 2, 12. And then we have m prime. What was it? -3, 6. Which we didn't have to answer, but we gave that. So this would be a new triangle. It is the image of this pre-image. Now we didn't graph anything. I suppose you could have. You could have counted it that way, but using matrices, we had this pre-image. The image that has these points right here is an isometry, which means the triangle still has the same area, congruent segments, etc., same angles, all that stuff. It's just translated this far over. It translated 5 units to the left and 10 units up, if you remember how those work. Number 30 is an example of using a compass and protractor. Now, I don't have a compass to show you on the screen because you can't see my hands and everything like that. So I will go ahead and try and design it as easily as possible so you can actually see it here as you would probably do it. But I do have a protractor tool, and I'll bring that out as soon as I feel like I need to. So let's map the black figure. Let's map the black figure onto the blue figure. Now let's rotate it about this point. I will go ahead and do it clockwise. I think the book might ask you to do these things counterclockwise. Only reason I say that is because one of the answers in the other thing seemed to indicate that. But I want to do this clockwise here. So the way that you want to do this is you want to take every single point. Find out how far away each point is from point C, and consider that to be a radius of a circle, where C is your center, and each of these points are, well, they're the distance away from C. So if you had a compass, for instance, you would take the sharp point and put it on C, and take your pencil point and you would put it on these vertices right here. And then you would end up drawing circles from that with your compass. So pretend like you had a compass and you drew circles. I'll do the exact same thing, only I'll do it with instantaneous brevity here. Oh, where's my dotted line? There we go. So go ahead and make 3 circles. Now again, you can do this with a compass. Might not be as easy as this, but you would end up drawing 3 circles. And these 3 circles are like, so for instance, this is however many units away from C, or however far away from C. All the rest of this is as well. So when we start going around, you see how this runs into this point right here? Well, that's because these points are, from pre-image to image, these are the corresponding images. These are the congruent ones. And when I go from this point all the way, oh, no, I guess right here, all the way around to this point right here, it's on the same, it's in the same area, and this point to this point. So we have to figure out what is that rotated angle, So so the actual rotated angle, let me actually darken one of the examples here. Let me do these two far ones. I basically want to get this angle from here to here. And you might have seen an example of me using this before. Let's call this angle theta. That's a Greek symbol. What is this variable theta? What is that angle? So this is where you use a excuse me, this is where you use a protractor. So I have a protractor here, and if you have not used a protractor before, it's pretty straightforward. Basically take it and only things, I don't really know how to rotate this. Dumb tool. But yeah, oh, here we go. So take the protractor and line it up with one of your measurements. So for instance here, if I want to rotate this down, let me line this up right with this purple line right there. And I want to see, well, let's see, this one's actually 180. Let me keep rotating this all the way down. So you'll have to look upside down for this one. So let me measure it up from the center to that purple line right there. So this is 0 degrees. So how far down? 10, 20, 30, 40, 50. So this is 50 degrees rotated around. Okay, so this theta right here is 50. Okay, so that's the kind of thing that it's asking. It's saying, how far did it actually go like that? So I think I can get rid of this compass now. And if you end up checking the other points as well, you'd end up seeing that, yeah, all of those end up being 50. So theta equals 50 degrees clockwise. Remember what the initial question was. Find the angle of rotation about C that maps the black figure onto the blue figure. So what maps this point onto this point? How many degrees did I rotate? 50 degrees clockwise. And I could do the same thing with all the other points. If I found out this angle from here to here, that's the same amount, also 50 degrees. And I should have been using different colors, but this point to that point is also 50 degrees clockwise. Okay, number 34. This is another part of rotation. Graph A at 5, 2. Okay, there's A. Then graph B, the image of A for a 90-degree rotation about the origin O. So O is at the origin. I'm not even going to label it, but I'll go and draw a little dot. Hint, consider the slope of, should be segment there, of OA. So they give you a good hint in case you ever get really confused about this stuff and you don't have a compass and protractor and you don't recognize a pattern. Keep in mind that everything, like 90-degree rotation, keep in mind that from O to A, or from the origin to A, there's a certain slope there. And that slope, if I go from O to A, remember what slope is. It's rise over run. It looks like from O to A, I go up 2, and I go over 5. And that can't be reduced at all. So the slope of that line is 2 over 5. So if I want to do a 90-degree rotation, if I wanted to rotate this thing down that way 90 degrees, I need to find the slope of the line that would be perpendicular to it. And so, so we just discussed that a little bit ago. The slope of that line would be its opposite reciprocal. So, and again, I never know what to call these. I think I called it MO last time, slope opposite. Opposite means negative, and reciprocal means flip the integers right here. So negative 5 over 2. And how do you draw that slope? Well, from this point, let's go down 2, or let's go down 5. 1, 2, 3, 4, 5, and let's go over 2, like so. I'll go ahead and keep it purple so I have a good-looking angle there, which should be 90 degrees. Oh, right, I have to do a line here. So let's